Yeah, so whenever we first download a file, a good thing to do is to run the file command. Does anybody know what the file command does? Yeah, it tells you what kind of file it is. So this gives us some good information right off the bat. So we know that it's a ELF 64-bit, so we know that we can run it on our Linux machine. Oh, yeah. Super zoom. So we know it's a 64-bit ELF. That's good. It's got Pi on it, which we'll learn about in the future. It's x86 64, so we're dealing with like an Intel type architecture. It's dynamically linked. That is something we'll talk about in the future as well. But most importantly, we see down here that it's not stripped. Does anybody know what it means for a binary to not be stripped? So if it's not stripped, that means like when you compile your code, usually the computer doesn't need nice names, right? Because a computer doesn't care about words, it only cares about numbers. So usually all your nice function names and all that get like thrown out and thrown away. Because usually if someone's trying to reverse engineer like your nice software you've made them pay for, you don't want them to be able to find like understand things quickly. So usually you take out all those names to make it harder for people to like reverse engineer your stuff. In this case, the people who made this nice little vault for us so graciously did not strip the binary. So we're going to have function names, which is a nice convenience. So what we can do is we can use a tool called GDB. It's the GNOME debugger. It's built into Linux. It's pretty standard. And we can load up our program Vault. There are, sorry. Oh, okay. So there's different extensions or tools or add-ons that you can use with GDB. One of them is called Jeff, GEF, and that adds a lot of nice, it's the GDB exploitation framework. So as the name suggests, you can use it to exploit things easier because it provides you lots of nice visualizations and stuff. There's also Pwn GDB or Pwn debug, I should say. That's also for hacking. So one thing we can do in GDB, especially if you're running optional tag B, is you can just say info functions. And since this is a non-stripped binary, it'll tell us all the names of the functions we have. So you can see it calls like strlen or printf, or the main function has a nice name to it. And it's also got a function called deobfuscate, which sounds pretty interesting. So what we'll do first is a pretty standard thing to do, especially when it's not stripped, is called disass on main. And I'm going to have to zoom out because we can't see all of main. Can all of you in the back still see the screen if I zoom it out a little more? Okay. So we scroll up here and we see, oh, sure.
So currently don't have GDB. Trying to install it.
Like if you try to call it, it should give you like the instructions to install it, and then you can just Control-C, Control-V, and it'll.
And it should just be a sudo apt install GDB.
Yeah, that's what I did.
Oh, it didn't work.
It's like unable to fetch a couple of files.
Interesting.
Sudo apt update.
Yeah.
Yeah, try updating. Oh, also, I guess one good thing before we start to dig through all of the main function and all that, another good practice when you're first getting a file is to just simply run the file. A lot of the times, if you can run the file, it's a good thing to just run it because, I mean, usually in the CTF, they're not giving you malware that's going to brick your machine. It's a nice person running the CTF, which most of them are. So running it's a good way to figure out like what's the general gist of this program, or are there like special things in there that might be of use. So if we just run Vault itself, we see that it asks us for a password, and we can type in yeet, and that isn't the right password, unfortunately. So going back to our analysis, you can see in main here, and thankfully we just all talked about assembly programming, so this doesn't look too horribly foreign to us, right? Right. Right. So we can see here the familiar push RBP, move RBP, RSP, sub RSP, some value. So that's doing what? Yeah, it's setting up a stack frame. So this is the beginning of the main function, of course. We can see that they make a call to malloc. So from our C programming experience, what does malloc do? Yeah, it's making a heap-based array. Yeah. And then we see some interesting things here. Ron, does these two lines, do they look sketchy to you?
I guess they look pretty sketchy. They look like some text right there.
Yeah, that looks kind of sketchy. I agree with Ron. So maybe there's something to do with these two large hex values, but we don't quite know yet. And then we can see there's a third line where they move some sketchy stuff. So they're moving it around. We don't know quite what they're doing yet. And then in line 84, they call that deobfuscate function. Interesting. And then they call malloc again. They call printf. And this is the first time they call printf down here. So what do we think this printf corresponds to? Enter password. Great. And then we can see right after that, they call fgets. So that's fgets is an input function. So that's where we type in our password. And then after that, they call strcomp. So what do we think strcomp is doing in this case? Yeah, it's comparing strings. Great. So in terms of the flow of this program, we know that strcomp here is where we compare strings. And if we look at what strcomp's arguments are, we're seeing that it's getting whatever is in RDX and RAX, because RSI and RDI are the two arguments for strcomp's function call. RAX is going to hold whatever is at RBP minus 10, and RDX is going to hold whatever is at RBP minus 8. And I'm trying to figure out if we can see if we go back to where the sketchy stuff got moved. So we're moving the sketchy stuff around. Like sketchy stuff gets put in RSI and then RDI. And then they place it on the stack somewhere. So principally what we can kind of think of here is this strcomp function is taking in, it's going to get whatever we type in, and then it's comparing it to the flag. Yeah, Ron.
Is there any way that we could edit this disassembled assembly, just take out that line and then just put true in the register that it puts strcomp into?
Yeah, so that's one technique called patching. So depending on the challenge, sometimes you have to put in a password and then it prints out the flag, which is something else. Or in some cases for challenges like this, the flag is actually the password itself. So you need to figure out what input would I have to provide to get the right answer. In this case, the flag is what our input is being compared against. So the password that we have to type in or figure out what to type in is the flag. Okay. So we need, if there's some way that we could just look at what happens when the strcomp is called, we could somehow find the flag. Yeah, sure.
Disassemble strcomp.
So strcomp is a library function that just goes through and just runs a compare instruction basically on each byte of a string, pairwise. We could look at that obfuscate function potentially. So let's try looking at the deobfuscate function. And we can see that it looks pretty darn ugly. In fact, deobfuscate is pretty horrendous. And sometimes if something looks really, really, really ugly, there might be a different way of doing it. So work harder, work smarter, not harder. we could try to figure out, like, backing up what the proper input would be. Because it turns out that from our disass of main, the sketchy stuff we see up here is actually the input to that deobfuscate function. So we could try to figure out how that deobfuscate function works, and then take the sketchy stuff and then try to, like, push it through. Or we could try to just stop the program right when it's about to call strcomp, and, like, in the processor, and see if the flag is just loaded in memory. So I think, like, one thing would be, like, write your own program, like, try to figure out how the deobfuscate function works, put the, like, sketchy byte stuff through that, your own deobfuscate function, and print out the answer. That's one method. But we're going to go with the dynamic analysis method of, we're just going to set what's called a breakpoint on this exact instruction here, right when they're about to call strcomp. Because at that point, both our input, which can be anything, and the deobfuscated flag, or whatever the password is supposed to be, will be in memory at the same time. And we'll be able to just steal the information, like, right out of the program. Does that make sense for everybody? So the way we do that is that we're at this strcomp function occurs at line 165, or like 165 offsets into main. So GDB allows us to set a breakpoint by using break or just the letter B. And we're going to say main. Notice you have to put a star in front of the name main, because name is not an address itself. So we put star and then the title of the function main, and then we can just add the number 165 to it. So we do that, and we'll see breakpoint 1 at 0x9D3, which corresponds in the text section here with the address next to the strcomp of 9D3. So then, say we want to run our program, we can just type in run into GDB. And when we run it, it'll start running the program. We'll see our familiar printout statement where it says enter the password, and we're like, sure. We'll say give us the flag, and then we hit our breakpoint right when it's about to compare, because that compare between what we put in and the flag happens before it says, like, you're wrong, have a nice day, whatever. And what we can see here is that the arguments that to strcomp, as we surmised, are the password, or what we thought, like, whatever we entered as the password at least, and the flag itself. So does everybody see how that works so far? So if you're running stock GDB and you don't have Jeff or PwnDebug installed, you won't have a really super nice printout like this. So I'd recommend installing Jeff or PwnDebug. In this case, so say you don't have Jeff or PwnDebug installed, but you know that if we go back up here, when we call strcomp, we know the arguments to strcomp are in what two registers? RDI and RSI, right? So even if we didn't have this super nice printout provided to us by Jeff or by PwnDebug, we could do info registers, and then this will tell us, here are, like, the values in those registers, right? So we know that RSI holds one of our arguments, and then RDI holds the other. So another thing that we can do inside of GDB is examine, so the letter X, and then we can examine as a string, so X/S, and then copy paste the address that we want to look at.
Can you do multiple addresses at the same time?
That I don't know, but you can just run a couple commands to like examine different addresses. I don't think you can look at multiple addresses simultaneously, but like X, when you do examine with the letter X, you're saying show me at a specific address and then show me in a specific format. So we did X/S, so the X being examine and the S being interpret the data as a string on the value in RSI, and we see that it tells us give us the flag, which is what we put in. So then if we do X/S on RDI, we can see that that prints out the password. So the commands we covered so far, or with GDB so far, were info registers or info functions, info registers, disass, which shows us the disassembly of a function of a particular function. We also talked about, or at least we just now looked at X or examine. And then we also talked about setting breakpoints. So setting breakpoints is one of the very common things you'll do with GDB, because often you'll want to set like a breakpoint right at the top of the main function, because say you don't know exactly where you want to stop, it's at least good to stop right at the top of main and start stepping through the program. Another good thing we should talk about is once you hit a breakpoint, say you want to run the next line of assembly to see like what kind of operations is this function doing. You can do that using the next instruction command. So if you just type ni, so see now we just called strcomp. Now we're on test EAX. And if we run ni again, now we're on the jump not equal instruction. So ni advances you one assembly instruction forward in the program. Yeah.
I keep saying my permissions denied to get into Vault. Like I can't.
Oh, you got to use Chmod, so change like the permissions on it. So Chmod 700 Vault, and that'll allow you to run the program.
How do you spell that?
CHMOD. Yeah. That's another thing. Before you can usually run the program, you usually have to change the permissions to allow you to run it. For those of you not familiar with chmod or Chmod, it takes a set of 3 numbers between 0 and 7. So that's in octal format. And what that's saying is read, write, execute permissions. So when you do Chmod 700, it's saying for the user, give them read, write, execute permissions. And then for group and other, provide no permissions whatsoever. Sometimes if you give it 777, then anybody can do that. So don't use a set UID binary as 777, because anybody will be able to get like root ability on your box, and then that's a bad day. Yeah.
I was trying to get GDB to update. I was able to like see all of this. Do you mind running through again?
Yeah, sure. Does anybody have questions about this work or this walkthrough so far?
Getting to say the person you got to, I wasn't able to. I was just like, I'm missing things.
Okay. I can help set up GDB for people if it's still kind of.
I got up GDB. I was trying to make a break.
Okay. Yeah, I think I'll stop the recording now just so that way it's a nice compact walkthrough of what we just did.
I really enjoyed